identify the quadratic function from the list below. So I'll just take a look at our first choice. So we have the square root of x squared. Now, the first thing I'd always like to do is if I can simplify stuff, I want to simplify stuff because that will help me understand whether the function truly is quadratic or not. If I look at this and I just say, oh, I have x squared, it must be quadratic, I would unfortunately be incorrect because I want to take the square root first. So the square root of any number squared is just itself. So this is then h of x is going to be equal to just x. That's it. It's technically plus or minus x, but don't worry about that for now. We'll take a look at that when we get to radical functions in a later chapter. So the next answer choice is going to involve x to the minus 2. Now, all quadratics do not have a negative exponent. Right? You cannot have a negative exponent in a quadratic. There is no simplification I can do here. Really, there's no manipulation unless I were to take this, assume that this is over 1. And if I flip that, it becomes 1 over x to the positive 2. But again, that's a problem because we have a variable squared that looks good, but it's in the denominator. We don't like that. All right, quadratic functions do not have that form. Okay, we need something to be positive there. Meaning in the numerator, it has to be positive. So that's out. The next choice here now, I already noticed, so I do have here an x cubed. Now that's a bit of a problem because I already realized that I might have a cubic function. Now, if you were to simplify this, and this is where it kind of gets a little bit tricky, but if you were to simplify it, you might say, oh, I can pull out a common term. I can pull out an x from each term, and that's going to leave me with x squared minus 1. Right, if I pull out an x from this, that becomes x squared, and if I pull out an x from that, it becomes a 1. Now you might say, oh, look, but that is a quadratic now. Well, this part is quadratic, but that's not the only piece of the function, right? You also have this piece right there. So that unfortunately would not be then a quadratic function. Another way to look at this is actually to graph this thing. All right, and that's actually a nice way to maybe determine if it's a quadratic function or not. I'm doing it more algebraically, but you can also graph these things, okay? And throw this into the calculator. Take a look at it. If it doesn't look like a smiley face, something like that, or a frown face, something like that, we're in trouble. And by trouble, I just mean it's not a quadratic. Not that you're in any type of danger. So last but not least, I'm going to take a look at this function. Now, by process of elimination, this would basically be the answer. But why is this the answer? Well, I have x squared. So that's a good start. But now over here, I have something that looks a little strange, right? And these are meant to be challenging. Now you might say, well, wait a minute, this x is in the denominator. That's a problem. X cannot be in the denominator. But remember, I said if you can simplify anything, you want to do that first and see kind of what the result is. When you take 1 divided by x and you multiply it by x, the x's essentially cancel, right? And you're left with just 1. So this is here to kind of trick you, right? The way to rewrite this is actually x squared plus 1 plus 3. So that becomes simply x squared plus 4. And that, my friends, is a quadratic. All right? So the answer is going to be right here. X squared plus 1 over x times x plus 3. Thank you so much for tuning in. We'd love to help you with more problems. Check out our website, glazersguide.com, for more practice and more fun. Take care.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.